No, no, that how can we take group photo? As the lectures are going on, I am taking screenshots now and then. Even the group, it will not come now. All people will not be appearing on a single screen. Physically, if it is happening, then it is okay. Ah, you are waiting for the resource person. Yes. Now the resource person has joined.
Vishwanath sir.
Sir.
Yes, sir. You are
Thank
able
you.
to hear?
I am able to hear. I am able to
Yes.
see you also.
Yes,
So,
sir.
right. Okay. We will begin. So you can share your screen, your slides, perhaps.
Just a minute, sir. I will do that.
Uh, Maybe meanwhile, I will introduce
Okay.
you.
Sure, sure,
I
sure.
will introduce you.
Yes, sir.
So now we are having with us Professor Suryakant V. Gangasetti, who is a faculty member currently at the KL University. Previous to this one, he was a faculty member at IIIT Hyderabad for 14 years or so. He completed his PhD from IIT Madras, and also he worked as a senior project officer at Speech Vision Laboratory, IIT Madras. He also worked as a faculty member at BIET, Karnataka, and he has also worked as a visiting research scholar at OGI Portland for 3 months. He has done his postdoctoral studies at Carnegie Mellon University uh, during 2007-2008. He is the author of about 150 papers published in national as well as international journals, conferences, and edited volumes. He is a life member of CSI, IE, IUPR, AI, ASI, IETE, ORSI, and ISTE. He is a reviewer for reputed journals and conferences. His research interests include speech processing, neural networks, machine learning, natural language processing, artificial intelligence, so on. Uh, he was also a local organizing chair for the conference, Interspeech 2018, which happened in India during 2018 at Hyderabad. So now I open this platform to Professor Suryakant. Professor
Yes, sir.
Suryakant.
Yes, sir. Yes, sir. I will switch off the video, and you are able to hear, sir, my voice.
Yeah, your voice we are able to hear. You
I
can
will
share
share the slides.
slides. You can share. There will be a present now button will be there.
Correct.
Now
Your
you
turn.
press that button.
Enter
Present now.
screen one.
Present now. Then
Okay.
entire screen. In that one. In that. Yeah. Now it's coming. Yeah.
Yes, sir.
Yes. It's coming.
Okay. Good. Good morning, sir, and very good morning, everybody. What is this? How many participants are there, sir? Just for information.
Actually, we are having 118 participants in total, but
Yes, sir.
attending participants are around 50, maybe 54, 55, like that.
As of now, later they will join. Are they
They
may
will join as we go ahead. They will join.
Okay. And all are from computer science background, or they are from ECE, or
It's mixed actually. There are several people are there from ECE as well as other branches. People are also there actually,
okay. All are
and
faculty members, no students.
all majority are faculty members. There are
Okay.
few PG students are there.
Okay, from your institute or some other institute, I think.
From our institute as well as from some other institutes, few PG students are there.
Okay.
And previously, we covered this neural networks back propagation,
Sure.
this LSTM, RNN. These things were covered in the
Okay.
previous lectures.
Okay.
So, yeah.
Okay. Very good. Once again, good morning, everybody. Welcome to my talk. I'm going to speak on machine translation, and this is motivated from the fact that because of the advancement in the technology, in terms of like producing the designing the electronic devices such as computers, the and in VLSI technology advancement, you see cost of the computers are getting lesser and lesser day by day, in also size of the computers. Once upon a time, in order to purchase some decent like configuration computers, it used to cost about more than 3 to 4 lakhs of a kind. And size used to be very big initially, and nowadays you see cost of the computing devices are almost negligible, about 20 to 25,000 rupees, or about 30,000 rupees you can get good configuration systems. At the same time, they are very powerful in terms of execution, the number of instructions per second. Therefore, uh, human being tendency is, wherever possible, replace human beings by computers, because very easily like can be things can be purchased, and computers are like they are tireless, they will do the task faithfully. Therefore, we feel that first step, if it is possible to do something by the computers, and if it is already done by human beings, why can't we replace human beings by computers? In this regard, the interaction between computers and human beings became inevitable, and the way we communicate to the computer could be sometimes by means of keyboard, then sometimes means of the screen, mouse, then whatever you see, video, all those things. And we know that most and effective communication between human beings is the speech. In that aspect, can I communicate computer to the computer also through speech? Because the way we communicate to the human beings by using speech in one of the languages is very effective, and it is very convenient, and it is very comfortable form. Therefore, we feel that it is also best suited interface between humans and computers. In this regard, an area of research called human computer interaction, or HCI, or what you call man machine interaction, has started, and it has progressed exponentially. But when you want to communicate with the computer through speech, it is not that much easy. Say, when I want to communicate or type some program or something, some information to the computer on the keyboard, I can do it if I know how to operate this keyboard and some of the language, whatever computer understands. Maybe plain English text, you are doing some documentation, or in one of the programming languages, high level languages, you wanted to try something. But same thing I wanted to do to the computer by using my voice as the input. At the same time, I need to have some devices, whatever we call as assistive speech technology devices, to provide information as input to the computer. And in the same way, say when I speak to the computer, it will understand what I am telling. It should do that. It should understand that first, then it will do that task. Then it has to, whatever the result opened from the computer, again, I need to hear it. I don't want to see on the screen. And I would like to communicate to the computer in one of the natural languages. In this regard, it is necessary to develop assistive speech technologies for multilingual speech. Why multilingual it is coming? Because in India, we have 22 official regional languages, and there are about more than 1,600 languages people speaks here and there. Therefore, multilingual, because when we speak, we always tend to borrow, say, one or two words from other language rather than our own. Say, when we are speaking in our mother tongue to somebody, then we'll not stick on always only the words which are from our mother tongue we are using. One or two words we borrow from other languages such as English, because of the whatever you say while speaking. For comfortability point of view, we use some of the other languages. And in this regard, as multilinguality is concerned, because India has a lot of languages, regional languages to deal with, in order to make human and computer interaction by means of voice or speech or whatever you something loosely we can say audio, then multilingual speech-to-speech translation assistive devices comes into picture. Then what are these assistive devices? Assistive devices are whatever you call tools, techniques, and approaches for making the computer to understand human voice or speech and then respond to it for any one of the natural languages. That is the intention. In this regard, we wanted to do this task by using computer. That's where computer is a machine. We are translating information which is there in one language to another language. We are processing the languages. Therefore, machine translation comes into picture. Now, broadly speaking, this multilingual speech-to-speech translation, in particular machine translation, mainly involves three steps. One is at the source side, When a speaker is speaking in one of his language to the computer through microphone, then ultimate aim is the person who is at other end, he should hear the same information from his sound box or sound system in his computer in the language which he understands or the language in which he is comfortable. Therefore, we have at this one end, source end, speaker is speaking through the microphone, then speech is coming out at the other end. What are all these involved in this process? See, nowadays there are like some direct steps, direct methods are evolved. Still they are like still in the what you call testing phase or whatever you call, they are still in the budding stage. People directly get the speech in another, say for example, I am speaking in English, then I now whatever I am speaking in English, you wanted to hear the same information in Telugu language as if I am speaking. That is in your system. We may be geographically anywhere. That is the multilingual speech-to-speech translation. Traditionally, researchers followed the following step. What is that? We know very well that computer is a data processing machine, or you can say computer understands only text. Computer cannot understand speech. Computer understand text. That's why we type the text, whatever may be, through the keyboard, and it uses for further processing. Even when you write a program in one of the high-level language like C, it's a sequence of statements. Each statement, sequence of words, and each words are the vocabulary of a particular language. You can say they are the keywords or reserved words of that language. Okay. Therefore, computer is good at understanding only text, and now we want all these tasks to be done by the computer. Task is speech spoken in English to be converted into speech spoken in, say, Telugu. Source language is English, target language is Telugu. Source language is say L1, target language is L2. Now, what are all involved in this? Of course, every stage computer is involved. Then, when I am speaking, I get a speech. It is nothing but acoustic pressure variation. When we have this acoustic pressure variation, it is to be fed to the computer through a sensor like microphone. It could be built-in or it could be external. When I speak, then it will come to the computer in the form of digital signal. Speech is analog and the computer is digital computer. Therefore, analog signal is converted into digital signal in the first step by means of something called A to D converters. Then, anyway, when I have the speech signal, digital speech signal in the computer means I have sequence of numbers that provides information. Information lies in the sequence of those samples, you can say. Then, using that digital signal or digital speech, I need to have a whatever you call program or module or app or whatever may be software. This converts, it will take input as the speech signal and it should give the corresponding text. So for example, now I will say good afternoon to the computer. Through the microphone, the speech will be recorded and comes to the computer. And output of this box, it should be this, good afternoon. Because this is a plain text, English, characters are from the English alphabet, your computer will understand. Given the speech, get the equivalent of text. The text carries the information, whatever the speaker is conveying. This is called automatic speech recognition. Whatever we have done, we have translated the speech audio signal to corresponding text. Why are we doing? Because every step we wanted to process it, and computer understand only the things of this form. It cannot understand this ups and downs, their acoustic pressure variation. Initially, computer meant for processing the text information. That's why the medium of instruction to the computer, or the way we communicate, most of the time still through using whatever you call text. Okay, now when I have the text as output of this, that is called automatic speech recognition. For this translation of signal into the text, we have a process called automatic speech recognition, and various steps are there. We will come to those steps, and there are certain issues that are involved in this. Then when I have the text in one language, for example, good afternoon, and it is converted into something called text namaskar, maybe namaskaram, or maybe namaskarandi, whatever maybe you can call in a particular language, that text in language 1 is converted into text in language 2 by using natural language processing. And when I have text in language 2, that is to be converted into speech in language 2. That is, this whatever namaskar is there, somebody should hear from the sound box. They should hear like namaskar. Assume that they don't have screen monitor at all. They have only sound box. This is called text to speech. And the heard speech, or whatever the information you heard, this namaskar, you should hear as if I am speaking, because that speaker quality also need to be maintained. Therefore, we have broadly 3 steps: speech to text, speech in L1 to text in L1, text in L1 to text in L2, text in L2 to speech in L2. At one end, we have speech recognition, other end, we have text to speech synthesis or voice generation. In between, we need to translate the speech in language, the text in L1 to text in L2. Therefore, entire thing, everywhere, translation is there. Using the computer, we are performing this translation. That's why this, whatever is called multilingual speech-to-speech translation, you can say, roughly say, it's a machine translation. Normally, people will use the word machine translation for, say, text in L1 to text in L1 to, because once upon a time, that used to be the extensive task. It is for various reasons. Therefore, and entire thing is a machine translation as speech in input is concerned. All right, we know in this process we need various speech technologies, assistive devices. What are all required? Main 3 things: speech to text module, speech recognition, text to text module using natural language processing, text to speech synthesis, which is called voice generation. In addition to these 3 tasks, see, this is broader. See, this is irrespective of who is speaking. You wanted like these are the 3 broader steps, but in addition to these 3 broader steps, we require assistive speech technologies such as who is speaking, speaker recognition, in which language he is speaking, language identification, in which emotion, in which mood somebody is speaking, emotion recognition. And when a speaker may speak in a language L1, he is familiar, but 1 or 2 words he may borrow from the other languages. Then code mixed speech processing. Therefore, these are some of the what you call assistive technology devices which are required or to develop or to address the issues for multilingual speech-to-speech translation. And now that is, say, in the computer. Now the same task. See, once upon a time, people used to use this using computer source place, computer at the destination place, and transmission through this. But we know very well nowadays everything's are on mobile platform. Meaning is that I have a smartphone, let us say, it has built-in mic, or even you can put external mic, does not matter. And when I speak through a smartphone, the person at other end to whom we have contacted or communicated, that person should hear from the whatever you call built-in sound box of their smartphone, and this person is hearing the information which is conveyed by the source speaker. So he is speaking in English, let us say sitting in somewhere in Delhi, and this person, she is listening whatever he is telling, say being in Bangalore, and speaking in Hindi, speaking in whatever you call in say Kannada or whatever may be the language. What we are doing here, machine to machine translation, speech to speech translation by using mobile platform, and now this is more difficult than whatever like traditional process where this is done by using computers. In what way it is difficult? In what way it is difficult is the following. In the normal traditional process, we have speech in language L1 converted into text in language L1 by automatic speech recognition. Then using natural language processing, text in L1 is converted to text in L2. And finally, get the text in L2 to do the speech. This parallel step and this module were absent earlier in the normal multilingual speech-to-speech translation where computers are involved. At the same now, if you wanted to do the same thing by using mobile platform, the communication channel, noise, everything comes into picture, because the person when he is speaking, it depends upon his comfortability, convenience. This may be at near end from the speaker, or it may be at the far end, or he may be speaking in the clean environment or in the noisy environment, and his mobile may be model of that may be different from this mobile, and this involves so many things such as effects of like channel. Another thing, say when this man is conveying something to this person, if you wanted to listen the speaker quality of this, then you need to incorporate something called prosodic information of the speaker. Prosody means the way the speaker speaks. That's called pitch, intonation, duration, intensity of the speech, all those things. Therefore, right from the beginning, along with this step, we process something called prosody also. Extract the prosody from the speech, then you have the text from the speech, take the text and the prosody, make it as a enriched text, not plain text. When you have enriched text in language 1, I have text in language 2 by using this NLP translation. Then I will incorporate that prosody which is there in language 1 in the text of language 2, that is called prosody implantation. Then we will get enriched text in language 2, then get the speech in language 2. It is the speech as if spoken by this person. Message is there, at the same time speaker characteristics is also there. Therefore, when somebody want to focus on addressing some of the issues in developing multilingual speech-to-speech translation system for the mobile platform or smartphones that can ease communication effectively. Otherwise, what happens is you are depending on the computer. Then you have to go to the place where computers are there. Then you can perform that. Rather than that, say many of us have the smartphones, and many of us are heavily use them. Therefore, anywhere, anytime, to anybody one can communicate in any of the languages. They are both are comfortable and familiar. And this is the difficulties, or you can say many more issues needs to be addressed for machine translation or mobile transport in comparison with plain multilingual speech-to-speech translation using computers. And nowadays you might have seen in the Google search, there is something right side, there is a mic. When you speak, it will convert into the text and it will search this like database, or you can say World Wide Web, and it will get the information. It will speak back to you. That facility is there. It is not still evolved, but whatever the facilities available, say for example, when you speak to Siri or Cortana or Google, hey Google, or Alexa, when you speak, you can ask it, what is the possibility, hey Siri, what is the possibility of like raining today in the evening. Then what it does is my speech, it will understand, it will convert into text, and it will go to one of the weather prediction website, and it will get the information about whether that it rains or not. Information is in the text, and again that information in the text is converted into speech, and it will tell back. That is one of the example of machine translation for mobile platform. Fine. In all these things, what is involved? Again, you can say computer involved, a smartphone is involved, or say in the smartphones. So this is very difficult to like embed or incorporate. Then sometimes something need to be processed in the cloud. Clouds are again computers, a parallel computer, supercomputer, GPUs, TPUs, all those things. And now, this is the technology. What is the research component, or what is involved? What is involved is we are making computer to use, or say small devices like smartphones also to use. Let us say this task is to be done by a human being. For example, when a Japan president comes to India, then there will be a translator. The person who listens let Japan president speech in Japan language, and immediately he convert into Hindi, or in Hindi language, we can say. He that translator converts into Hindi. Then our Indian president will understand that in Hindi, and he reply back in Hindi. Then this translator immediately converts whatever heard from Hindi Indian president, and equivalently he will speak the speech in Japanese language. That is one example where human is doing this translation. Whereas in order to use machine to do the translation, see, human beings are very good. Some people are trained. Some people have whatever you call that experience. They does the work effortlessly. What about using computers? Now, that's where we make something called artificial intelligence or machine learning comes into picture. That is the one of the reason I think everybody nowadays interested in AI, ML, and we know that this AI and ML concepts are useful in most of the areas wherever it is possible, not necessarily computer science or electronics or engineering, any branch of engineering, any branch of science. There is nothing like this artificial intelligence, machine learning. Now it became like discipline independent. That means anybody can use for any task. Then why this became so like famous, or why people use everywhere like machine learning AI techniques for making machine to behave like human beings. What is my why I brought this machine learning AI words in this concept is that I wanted to like do this automatic speech recognition the way human being does. When I am speaking, you can make a notes of that without any difficulty. You are hearing and you can write whatever I am speaking. Say when somebody attends somebody's lecture or class, they can make the notes whatever somebody is speaking as it is. Then it is a speech recognition. How human being does, that does effortlessly without any difficulty. At the same time, assume that now it is something is there on the screen, the machine translation for mobile platform. If somebody asks you to speak out, then you will speak out. Machine translation for mobile transfer platform. That is the synthesis. That is from the text you are spelling out the speech. When somebody is speaking, you are you are generating the text of it. Human beings does this effortlessly and does less mistakes. In the same way, I want computer also to do that task because as I said initially, human computer interaction wherever possible, I wanted to like replace human being task by computer. And in this regard, human beings, whatever they are doing with their experience, I want computer also to do in this way. For example, I want computer to do speech recognition, computer to do speech synthesis, computer to NLP to translate text from language one to language to prosody extraction, implantation of the prosody, so that you can get the enriched text and enriched speech of a kind. These are all to do these things. Technology or what inside logic or inside like whatever we are doing. This is like by using artificial intelligence and machine learning techniques. Then normally artificial intelligence means like quite number of times people refer some standard book like Artificial Intelligence, a Modern Approach by Stuart Russell and Peter Norvig. This is one of the famous book. And we have another book also, Rich and Knight, AI, Artificial Intelligence, and Alan Rich. And there are two these things in the artificial intelligence. One is classical AI, classical artificial intelligence. Another one is modern artificial intelligence. Classical intelligence, classical artificial intelligence. What is artificial intelligence? Creating intelligence artificially in the computer or some machine, some device should behave like the human being is performing the task. Machine, that doesn't mean that always computer. It can be lathe, it can be mechanical device, it can be electronic device, it can be some other device. And in that AI, for example, we wanted to replace human being by computer, then people study something called philosophy of AI, and after that they think everything, say every solution to any problem already it is there. Solution to any problem already it is there in the human mind. See, in the human mind, solution to the problems are there. What are we doing? We are searching that solution to the given problem. Therefore, the search techniques comes into picture. Then later people went on to something called game playing. Initially, AI for game playing because say if a computer can play a particular game with the opponent as the human being, and if it can defeat the human being, if it can defeat the human being, then we can say computer is intelligent. Why people were interested in like addressing some issues related to game is that if somebody plays the game, he or she is considered as intelligent. So somebody plays chess, oh, he knows chess play, he plays chess very well. That's why like sports are very important. If the computer can defeat other person, or if we can make the computer to play the game like human beings plays, then we assume that computer is intelligent. Then at various places, apart from game playing, you need to plan something. Then automated planning, AI came into picture. Then next biggest problem is how to represent the knowledge itself as a challenging. That's where predicate logic, first order inductive learning, so many other logics, fuzzy logic, genetical, probabilistic logic, those are all came into picture. as this is concerned. These are all like comes under whatever you can say traditional logic, traditional artificial intelligence, classical artificial intelligence. Then came something called modern artificial intelligence because people felt that there are some limitations in the classical artificial intelligence. Then this Markov decision process (MDP), it is the like extension are related to Markov process. Then hidden Markov models, Markov process, all those things. Finally, all these things is these concepts, all those things are for what? Making machine behave like we are making machine to learn. What do you mean by machine learning? Machine learning is in case of normal learning, input and programs are given to the computer. That's why we write the program, we'll execute it by giving the proper inputs, then we get the output. That is normal like learning. Whereas what were expected in machine learning, you are given the input data, you are given the output information, computer to learn the program, learn the idea which has generated this output from the input of it. That is machine learning. And by using machine learning techniques, some of the difficult tasks, complicated tasks, once upon a time assumed those are to be very tough tasks. Nowadays, those are a little bit became easier. I can't say they have solved the problem 100%, but they are like easy, little bit better in terms of recognition or accuracy, whatever you call, because of the large amount of data is available. So making machine to learn or making computer to recognize this somebody's speech, what is required? You require huge amount of data. And again, in order to synthesize this, you require huge amount of data to get the model. Train the models means what you are getting. You are developing the models with or you are generating the system which has generated that data. And in order to understand the system which generated the data, you require huge amount of data. But nowadays, because of the like where data is available in social media or by using like sensors at various locations or say World Wide Web, you have a lot of data. Data gathering is not that much difficult nowadays, and therefore that's where like machine learning from the data given input output came into picture. In that regard to then based upon data we are, I think I am sure sir told also that you have studied various neural network models, fuzzy logic, Bayesian networks, all those things. And we felt that people felt that in addition to these classical inductive learnings like neural network models, whatever you can call stochastic processing models, now came into picture something called reinforcement learning, which are all very much useful. You know the goal, you know the starting point, but you don't know the intermediate steps. And in order to reach the goal, you require many number of steps. That's where reinforcement learning came into picture. Then using something, all these things are done using soft computing approaches. Soft computing means anything, the genetic algorithm, swarm optimization, all those things. And these are all, some of these becomes very much useful in natural language processing, such as machine translation or multilingual speech-to-speech translation. Now, what are the machine learning approaches we are using in our task of multilingual speech-to-speech translation? Before like going into details of those things and how are we using those things, let me tell something about, in general, what are we studying in machine learning. Machine learning, making machine to learn. Machine means computer to learn. Computer means some electronic device. Broadly speaking, we have supervised algorithms, unsupervised algorithms. Then I told something called, apart from the supervised and unsupervised, we are having reinforcement learning and analytical learning. These are all learning the rules. Okay. And in this regard, you will be having pictorial representations of graphical models. That something can be represented by means of whatever you call pictorial representation. And supervised learning, you might, I'm sure you have studied something, this logical regression, neural network, decision theories, nearest neighbor method, support vector machines, Bayesian based upon probabilities concept, neo bases are there, maximum likelihood and maximum error estimation, Bayesian optimal classifier. Again, we and these graphical models, there are two types, generative and discriminative. In that regard, there are some models called generator, gap generator, uh, generator and adversarial networks. Then, in case of supervised, we know the desired output. That's why it is called supervised. Somebody is given that this for this input, this is the output, target output. Then, in case of somewhere, sometimes we don't know that target output, or we don't want, or the problems are such that that concept of target output does not comes into picture. So, I wanted to categorize some of the things, and like by like knowing the processing the data among them, so these are all belong to this category, these are all this, these are all this affected. That's where clustering came into picture. And to optimize this clustering algorithm, we have expectation maximization. Then you have to assume some of these things, like which system has generated this data. Then Gaussian mixture model came into picture. Then for extraction of the features, or to reduce the dimension of the pattern vectors, to reduce the noise, we something called principal component analysis concept is there. And there is and probabilistic and this one learn, all those things came into picture. All these either machine learning, AI techniques, like became like so handy in application like machine translation, natural language processing, computer vision application, web applications, and so on. Depends upon like interest, depends upon the area in which you are working. These are all will be very much helpful, and we know that this machine learning, there is a standard book, Machine Learning by Tom Mitchell. Uh, he started writing, I think first book came in 1997. And he has written that concept of these things very well. Anyway, AI and ML, why I brought this brief introduction, syllabus, and some of the things into picture is that my intention is not to teach AI, my intention is not to teach machine learning, my intention is to use those approaches in my task. What is the task? Machine translation is the task. What is the machine translation as I am concerned? Multilingual speech-to-speech translation for mobile platform. Then, what are we doing by using all these things? We are making computer to be intelligent. Intelligent in what sense? It should be able to recognize my speech in English, and I am speaking through a microphone in my whatever you call laptop or desktop, and you are hearing in your computer in say Hindi language. In between, say if there is some translator who can, human being who can listen my speech and convert to the speech you understand, say English to Hindi, that is human intelligence. I wanted to make it computer intelligence because I wanted to use machine. Then what is this intelligence? Can computer be intelligent? Can we make computer to be intelligent? Then before, like whether we can make computer to be intelligent, is we have to define first intelligence. Intelligence is something which is related to creativity, skill, consciousness, emotion, and intuition. And when somebody has these things, somebody has skill, somebody has creative, and somebody is very conscious, or somebody speaks emotionally, somebody can find, somebody can guess something, things going to happen in future with intuition, then such human being we call intelligent. In principle, all human beings are intelligent, and if you consider these as the measures, then maybe then all these things will be useful to find intelligent quotient. Then a measure of say IQ is more than 70 is good, intelligent, more intelligent somebody, 60 it is less, then 80 is still more of a hyperactive, hyper intelligent, all this. And all these modern computers, whatever maybe whatever we are using, the father of modern computers is called Alan Turing. He used to think like this: machine could be created that would mimic process of human brain. That means computer can one can develop the computer, one can design the computer. This, for example, multilingual speech-to-speech translation can be done easily. That is the meaning. Why you want computer? Assume that here is Japanese president, next to him Indian president, in between a translator is there. He simply listens Japanese language, convert into Hindi, and he listens Hindi language spoken by Indian president, then he will, that fellow will speak translator to Japanese president in Japanese language. Okay. And now human being, I told I wanted to replace that human being is intelligent, then we can develop the systems or machines that could create that would mimic the process of human brain. And let us say there is, don't see the slide, what I am saying you can listen. Let us say one side I have a natural problem, I have a problem to be solved, and other side I have, you are given one problem to be solved, natural problem, and you are also given a well designed computer, a very sophisticated computer, you can call powerful computer. And if you cannot solve this given problem by using this sophisticated computer, then no human being can solve this problem. That is, a problem is there, computer is there, sophisticated. If that problem cannot be solved by the sophisticated computer, then that it is impossible for any human being to solve that problem. That is, we are overestimating, or Alan Turing overestimated the what you call computer power. But even after 70 years, we are too far from his, we are still too far from his visionary, or too far from his expectations. Human, any of you able to see something is there on the screen? Any of you? Hello? Where is that? Any of you are able to see what is?
Yeah, I am able to see the screen.
Yeah. Just I'm asking to that this one, sir. Participants or anybody can. What is there on the screen?
We can see that some politician is there.
Yes, you are almost near. Yeah. Yes. You said Bihar rightly. You said politician rightly.
I don't want to give you that name of the politician.
Okay. But I know. I think you know that story.
Yeah.
Okay. Say yes. What sir rightly said it is the following. Some politician is there on this whatever creature. You can call it as a cow. I think that politician is now no more active politician. Of course, he is not enrolled. Does not matter if I take the name, or let us not take. Say this politician is on the screen, maybe from say is on the cow, is the Bihar. So now what happens is, if I give this as input to the computer, can it give me one page of essay what the cartoonist is intended to describe in this? That is the question. That means, can it summarizes this picture or image, or can it can we get the summary out of, see what is the story? Story is very big. Don't say story is on the screen. A very big story, and describe it in terms of cartoon. And see, during this politician period, when this politician was chief minister, then lot of, whatever you can say, huge amount of um, budget was allocated for providing free of cost grass or food to animals. And we know very sophisticated and very animal is a cow, therefore it is a cow. In general, for animals or cows, huge amount of whatever budget allocated for providing free of cost grass or food to cows. But in the process, what happened is, after allocating huge budget, they did not do the proper job. Politicians, ministers or cabinet, this does not do the proper job. That means the budget which allocated for this task has not reached properly what it intended. That is grass. It is not given to the cow. It is holded little bit away. Where in Bihar, that is the story. It became a very big scam called fodder scam. And how Vishwanath sir is able to all of a sudden see, by seeing this image or say whatever you call, there is a cartoon able to link. See, he said Bihar. Human beings can make this is Bihar because somebody is there and somebody is there and a cow is there. But actually, see, these may be the bones and skeletons of the cow, because when I remove the skin of the cow, bones and skeletons appears like this. When computers start doing the things, say pixel by pixel, or say some sequence of pixel, or say some like a square number of pixel, 3 by 3, 6 by 6, whatever may be, ultimately it may not come up with the story like a Bihar politician is there, some grass is there, cow is there. This may be the something related to the fodder scam or something of a kind. Computer cannot, because it cannot link. Computer cannot visualize globally. It visualizes only locally. That is the main. Hey, I wanted to make computer to creative by using these approaches for my task. Multilingual speech-to-speech translation, we do effortlessly. Say, I am speaking. How are you? Then you immediately will say, "Ela unnaru." Of course, maybe like "Aap kaisa hai?" The some simple sentences can be converted by the human, and like human beings are very good. They can convert, like if they know both the languages, they can do it very easily. But for the computers, it is not that much easy. Why it is not that much easy? Because it starts looking bits and pieces. It cannot think globally. Therefore, coming out the message, what is conveyed here, so much hidden information is there. I don't think computer can identify so easily what is the essence or what is the story cartoonist wanted to tell in this African. That means how far somebody is there to make computer to behave like human beings, because the way human being process the things is different from the way computer process the speech. Human beings does pattern recognition task, computer does data processing task. Human pursues cues, edges, those are so important. For example, if I say like this, that is more than sufficient, that one cough is more than sufficient, that sneezing is more than sufficient to identify sometimes who is he. You need not have to see even the face. Fine. Next one I have written. Next one here, say first leftmost, says there are four. First row first column, first row second column, second row first column, second row first second column. Okay. In this, see, if you start staring at the screen, initially it may appear like what are all this, say red, black, green of a kind. And if you move little bit away from the screen and you start thinking what is there in the first row, first column, something is there. What is there? Again, what is there in the first row, first column, are some just pixels, random pixels are there. Anybody? We have something called face. Inside there is a face. See, this is the mouth. This is nose. These are ears. Then you concluded there is a face. Though there is a noise, face is not totally visible, but you can see there is a face. And still, the second row, first column, this, though there is more noise, still you can make out there is a face. It's a little bit difficult. See, human beings are very good at in this, but how about the computers to uh, do this kind of task? Anyway, for example, take all these things. All the faces are different. Nothing is identical. But all this belongs to a single person face. You can make out because see all faces, nothing is common, but what is common? Person is common. What meant by person is common? It is very difficult to say what is common. But we will say all these things are belongs to a single person. In the same way, you see this, you can say this person is there everywhere, or this person is somebody and he is here African. In the same way, for example, this is totally different from whatever is there in the previous these things. But still we will say this person is here, same person is here African. A human being don't have any difficulty to recognize somebody's face. But how computer does is not a that much easy task. And again, for example, same person to identify in the scene, there are about 30 faces are there. Among them, to identify that person face, somewhere it is, I think this is that person. With some difficulty, you can find maybe in some number of trials, or at least it will convince, oh, this is that person African. But totally it is different from whatever they were there here African. That means the way human being does a task is different from the way computer does. Of course, computer has limitations. They cannot reach to the intelligence of the human beings. But somebody predicted that in another 140 years, that means 2160, the entire world will be full of robots. No more human beings. I don't know what robots may kill the human beings, or robots may dominate the human beings, or when all around us there are robots, then we feel that like this is an artificial world. It is like no more the whatever earth was there, let us not to be here African. I do not know, but people predicted on this earth there will be only robots. Meaning is that all the tasks done by human beings will be replaced by robots. Then all our faculty development programs or whatever may be taught by the robots, listened by the robots. I don't know what for that is. Anyway, now my intention is I wanted to perform this speech signal to symbol translation or transformation. So this is given. I want. That is, you are given the speech signal, you want the sequence of text. That is, what I am doing is speech to text. And why you want that? Because that is our first step. Take for example here, that is our first step, speech signal to symbol transformation. That is our speech to symbol. Or you can say speech in language alone to text in language one. That is our first step. Therefore, we require whatever this. When I have this, given this, then this is easily processed by the computer. For example, now some result is there. For example, this. You are given this. You wanted to synthesize this. How are doing? There is a speech synthesis. See, when I click this, move. This is given. You wanted to synthesize this. This is called speech synthesis. Therefore, we are interested in speech recognition using machine learning, synthesis by machine learning, translation of the speech from one language to say text from text in one language to text in language to again by machine learning, that is by using machine. These are all we require for machine learning tasks. And synthesis, see for example, you have studied recurrent neural network. As this is say machine learning, speech signal processing is concerned. Just I will share one more slide here. Okay. So that okay. Now, what is the speech to whatever you call speech signal to symbol transformation can be shared approaches. Yeah, they can see this, right? I need not have to share the screen. They will see this. Yeah. See, for example, here, speech signal to symbol transformation. If you wanted to do this, then what are all the difficulties? First, I need to understand how speech is produced by the human beings and it is pursued. Next thing is production mechanism you need to understand, perception mechanism you need to understand. Then we have different kinds of sound units. There are roughly say 48 sound units in say Indian language like Telugu of a kind. For this, that is speech signal to signal transformation, we call it as phonetic engine. That is, there are different approaches like segmentation, labeling, and spotting based approach. And the segmentation is given the speech signal, segment into basic sound units, then assign label to each of the sound units. Another spotting based approach, it is like don't identify the segments because it is a difficult task. Therefore, spot some of the events of interest such as oval answer points or some anchor points in the continuous speech. Identify the anchor points and assign label to the a label to the region around the anchor point. That is called spotting subordinates. But main biggest issue in development of the speech recognition system is what should be the basic unit for recognition. That is called choice of subordinates. Can I use phoneme? Can I use syllable? If you use phoneme, then you will be having 48 phonemes. And if you use syllables, even in the simplest form, syllable means consonant followed by vowel. That is the way we speak. Phoneme cannot be spoken in isolation in most of the cases. The number of subordinates become C into V, 36 consonant, 12 vowels, 436 into 12 is 432. If you use phoneme, 48. If you use syllables, 432. Then we have what you call, then all sound number of subordinate classes became more in number, but human being speaks things in terms of syllables, not in terms of phonemes, because of the constraint by the production of these sound units. Then frequency of all the sound units will not be same. Different sound units occur at with different frequency. Will not you speak all the sound, all the say words exact number of times. Some words are spoken more frequent than another. Then for the same say word, when I speak now and when I speak next time, characteristics of the signal varies, depends upon the mood, depends upon the production mechanism. Then, but when I say same word now or afterwards, message conveyed is the same. That is, there is acoustic similarity. Then comes, all right, all these things are, we don't have control over all these things, 1 to 5 issues. Then ultimately models has to be developed to recognize the sound units. That's where classification models, machine learning models comes into picture. What kind of models I need to use? Then how to represent the subordinate itself, because subordinates, whatever we are having the speech signal, you are having speech signal, how to represent like phonetic information there in the acoustic speech signal. Then dimension of the pattern vector also plays an important role, because when you represent some sound unit by number of features, dimension became more. When dimension became more, there will be more sparsity. Then how to compress the dimension of the pattern vectors. Then recognition of sound units in one language, recognition of sound units in multiple languages. Those are all the issues. But there is, what is the engineering part here? 6 to 10 points are engineering issues. 1 to 5 are, you can say, phonetics and phonology issues that we don't have control over that. They are, therefore, can we do something better in case of 6 to 10 points to do the things like recognition, performance in a like reasonably acceptable like accuracy of a kind. Classification models, there are different kind of classification models: hidden markup models, multi-layer fit for neural network models, support vector machines. These are all based upon whatever you call stochastic process, statistical models. It depends upon the large amount of data you need to gather, and you need to get the parameters such as mean, variance, standard deviation, and so on. Usually based upon means and standard deviation, you can find probability of this world, this signal belongs to this world of a kind. That's where whatever you call Gaussian distribution comes into picture. But parameters are estimated better if the data is very large. There is no upper limit for the amount of data. Then people moved on to something called multi-layer fit for neural network models and support vector machines. And these are all inspired by the way of human being learn the thing. These two are based upon the uh, discriminative learning, and this based upon maximum likelihood learning. Any day discriminative learning is better than maximum likelihood learning. That's what researcher says. And that is the reason, like we go for whatever you call this MLFF, SVM, all those things, they are called soft computing approaches. And the soft computing approach, constructing computationally intelligent system, because we want the multilingual systems to be computationally efficient. What is this intelligent system? Is an emerging system that computes parallel remarkable ability of human mind, reason, and learn in an environment of uncertainty and imprecision. Because speech processing or machine translation and speech translation is a complex real world problem, they require intelligent system. We require to combine the knowledge, techniques, and methodology from various sources, because human beings get the information from whatever you call from various sensors, and knowledge integration takes place in the human brain. That's where like biological neural networks came into picture, and one among biological neural networks is called multi-layer feed for neural network, and multi-layer feed for a neural network does the pattern recognition task. And we explore whatever you call yes, for the speech recognition. And this multi-layer means 4 layers. When there are certain difficulties in see this traditional 4 layer neural networks for training to for the speech processing task, or in general any task, then now we are using some kind of what you call deep neural networks and time delay neural network for speech processing. And artificial neural networks, we have still difficulty, because we have to incorporate knowledge of the speech knowledge. We don't know how to incorporate problem domain knowledge, and what amount of data can we get the right data from various speakers, all those things. Then we explore something called support vector machines are also there. And support vector machines, we have what is called linear surface for hyperplane. Optimal hyperplane is the decision boundary or line. Then these are all what you call, once upon a time during 2000 or so, people used to use support vector machines because they are linear processing units. Then they used to construct optimal hyperplane, and it's a two-class classification. If say sound units like speech processing, when we have about 36 consonants and 12 vowels, then 432 classes, then it became multi-class classification. Then we explored one against the rest approach for what you call speech recognition. This is totally for SVM for all those patterns and evidence we get. Finally, we decide to which class this input pattern belongs of a kind. Issues with respect to support vector machine is they are suitable for classification of fixed dimension patterns. Any neural network model requires fixed dimensional pattern vectors, and classification using experience is computationally intensive. In this regard, we explored what you call autoencoders. Nowadays, people will say auto-associated neural networks. Explored it for feature extraction as well as dimension reduction. Um, for the this is one of the this one for the like this is the structure of the autoencoder. Input is same as output, and this is a symmetric neural network, and you can use it for dimension reduction when the patterns, if you wanted to get the information at this point, or you can use for distribution capturing ability for each of the sound units. This is what related to what you call uh, speech recognition. Let me come back to the what you call. This is my next module, whatever you call. This is say speech recognition. You can have what you call sophisticated model like nowadays time domain neural network models for the speech, deep neural networks for speech recognition. Simple multi-layer feed for neural networks will not work because of the large amount of whatever you call impreciseness is there in the data, as well as number of classes are more in number. Then as this speech synthesis is concerned, whatever you call speech synthesis, I have that. Yeah. We explored something called recurrent neural network for speech synthesis. Why? What is the necessity? Why we use recurrent neural network for speech synthesis is, say, once upon a time people used to use hidden Markov models for speech synthesis, and they used to tune the parameter like mean variance and to change the and it became very difficult in case, for example, in traditional speech synthesis, you have some, say, you have that speech synthesis means what? You have the text, get the speech. Then for as training is concerned, you have the text and corresponding speech. You have in the text how you represent categorical features, numerical features, durational features, and speech features. They are spectral features, provides the information of the frequency content of the signal, and whether it is periodic or aperiodic, that periodicity features, and speaker characteristics is F naught or fundamental frequency. Neural network models used to use for mapping the text to speech from known data. When this is trained, then when a known text comes, then you get the corresponding spectral features, aperiodicity features, and F naught by using vocoders, voice synthesizers, get the corresponding speech. This is traditional speech synthesis approach, whereas we explored recurrent neural network for speech synthesis. What is the advantage? What is there in recurrent neural network is the following. Say this is what you call your recurrent neural network. If I unroll, that is timestamp, say at T1, T2, T3, and so on of a kind. What this structure is providing compared to just feed forward. See, you have feed forward and you have feed forward neural network, multi-layered feed forward, and you have connection, see, connection among the units in the same layer. That is not there in case of feed forward neural networks. Whereas recurrent neural network, you have connection among the units in the same layer. What that provides is the following. So this is trained by using multi-layered feed forward neural network for getting the information, input to output mapping. At the same time, say h of t is given is a function of WIXT plus WHT minus 1. That is horizontal information at time t is represented in terms of previous timestamp, and this ht minus 1 in ht minus 2, and so on. Therefore, this kind of networks, recurrent neural networks, has advantage of acoustically guided contextual information. In speech synthesis, context is very important. Context means a present sound unit is in the context of previous sound units, in the context of next sound units. That's what you call the prosody knowledge. Prosody knowledge can be easily easily what you call modeled by using what you call this recurrent neural network. Recurrent neural network we have explored for speech synthesis for 3 of the languages: Hindi, Tamil, Telugu, and since implicitly the context information is captured, acoustically guided contextual information, so quality of the speech is better when you use the recurrent neural networks. And as synthesis is concerned, synthesis is what you call little bit you can say more tougher, or you can say more issues that needs to be addressed in comparison with the recognition. Now, so what is given in the synthesis? A text-to-speech synthesis. Text is given, synthesis the speech, and say this is there. Then there are different kinds of TTS systems. One is limited domain, another one is unrestricted domain. Limited domain text-to-speech synthesis is easy to produce because you have limited vocabulary, limited words. Whereas for unrestricted, like text-to-speech synthesis, any kind of words can come, any kinds of anything can come. That is, for example, news reading, storytelling, desk assistant. These are all called unrestricted unrestricted text-to-speech synthesis. How as I said, RNN we are exploring it for like a speech synthesis. We have explored recurrent neural network for speech synthesis task, and we have explored what you call DNN for the speech recognition. Sir, what shall
Sorry,
we do? Yes, sir.
you are having 5 more minutes, sir. Actually, the session has to end at 11 o'clock.
Sure.
Maybe we can ask the audience for a couple of questions also.
Okay.
So, yeah.
Shall I speak another 5 minutes, or shall I stop?
You can speak for another 5 minutes, and then for 5 minutes we may open it for question and answers.
No problem, sir. No problem. Yes, sir. Yes, sir. Yeah. Now, what I have done in this study is that wherever possible, we explored what you call machine learning approaches for machine translation. That is automatic speech recognition. Even for extracting the features from the given speech signal, we can use neural network models, neural network models such as, for example, principal component analysis for feature selection. Or you can use something called associative neural network for extraction of the parameters. And traditionally, we use something called null frequency capital coefficient for feature extraction. But before that, people use linear prediction capital coefficients, based upon linear prediction analysis. You can use machine learning approaches itself for extracting the features. And their autoencoders nowadays are very much like became handy. Autoencoders, take for example here, as I said, autoencoders, approaches. There itself I must be having. When you see this autoencoder, see it can perform multiple tasks. One is it can do the dimension reduction. The way it is trained is that give the input, tell output is same as input, that is reproduce the output at the input at the output layer. When the network is trained in this way, then after training, now when new data is there, then give input and collect this. For example, this is 100 dimensional, this may be 10 dimensional. You are doing 10 dimensional compression, that 100 to 10. Or whatever you are say giving the input, like if we can collect output at this layer, then they are different features. Or you can collect output at this layer, they may be the different feature. Or you can collect this at the output layer, they are different one need to explore what are all different layers are learning or different layers are doing of a kind. In this way, we can explore auto-associative neural networks for various tasks in speech processing. That is about like features at the yeah. Now, as prosody is concerned, prosody means basically intonation, duration, pitch of the speaker. When you want to extract that, you can train the neural network itself model to like learn the prosody from the speaker. And what kind of like neural network models? I need to explore what kind of neural network suitable for that kind of task of a kind. Then synthesis, we explore recurrent neural network because they capture the sequence knowledge. And for example, translation of the speech from one language to other language, you can even use hidden Markov models because there you can sequence knowledge is very much useful of a kind. Therefore, as DNN, RNNs, and coming to there are some other tasks such as, for example, you can use CNN. CNNs are nothing but convolution neural networks that themselves can be used for extracting the features. CNNs are useful extract the. See, I don't know what features are suitable for my machine translation task. Then I will ask network itself to learn the features. Say CNN initially feed the raw speech, or you can feed the spectrogram. Then what you call it itself will learn and it does the classification better of a kind. In this way, you can explore convolution neural networks for like extraction of the features in machine translation. And nowadays we have some kind of new neural networks are coming called GAN, generative and adversarial neural networks. What is that is done is that itself can be used for what you call synthesizing the speech data that is to data augmentation. Meaning is that but try to synthesize the data wherever sparsity is there, scarcity is there. By using GAN, you can synthesize large amount of data. That you can explore generative and adversarial neural network models for like increasing amount of data we wanted to train the models of it. In this regard, various neural network models can be explored for machine translation. In particular, as my area of this one is concerned, we have explored multilingual various neural network for multilingual speech-to-speech translation. Sir, I have done.
Okay.
Yes,
thank you, sir. Now the forum is open for question and answers.
Sure.
So please raise the questions from the audience, please.
Okay. Maybe I can stop sharing.
Good morning, sir.
Yes, sir.
Good morning, sir.
Very good morning, sir. Yeah.
Sir, for regarding, regarding for biomedical signal, which model is suitable to analysis for classification tasks, sir? For biomedical signal like electroencephalogram signal or either electrocardiogram signal, for which model is which deep learning model is suitable, sir?
You are talking about EEG?
Yes, sir.
Okay. What you wanted to classify? Assume that when you have a biomedical signal, how many classes are there?
5 classes are there. There's 5 classes.
Which are those?
Wake stage, N1 stage, N2 stage, N3 stage, REM stage, sleep disorder, sir.
Okay. How many examples are available? How about data available for each of these classes?
For each classes are around 700 epochs, means total sir epochs 12,000 epochs, sir. Each epoch 30 seconds. 12,000 epochs for all the sleep stages, sir.
Acha, my thinking is if there are 5 classes, then simple multi-layer feed for neural network also can do. You need not simple multi-layer feed for a neural network also can do. You need not have to go to deep learning, because if you go to deep learning, the problem is you need large amount of data.
Yes, sir.
Yeah. You can try with even multi-layer feed forward neural network, and that is the thing.
So
And
some of the literatures I have gone through, they have approached that CNN model.
haha,
Though EEG signal is having sir one-dimensional form,
correct.
how actually sir can we convert that signal into the image format? Then after we apply, or directly signal can we apply with the model, sir?
See what happens with respect to CNN is that concept of CNN came from image processing.
Sir.
Okay. Then in the image processing, image is a 2D signal. Therefore, that entire setup or the way that evolved is input given as two-dimensional. That's why somehow your data is to be representation is to be converted into two-dimensional. How you are going to do that two-dimensional? Assume that you have one-dimensional signal. Best is to find spectrum or spectrogram of two-dimensional and feed it to the CNN setup.
So means that signal we need to convert to spectrogram representation, sir.
So some kind of two-dimensional representation,
Okay, sir.
because that's where I think initial layers are called, what is that is called, a convolution layer and pooling layer, all those things. If we wanted to use for one-dimensional, then I think you need to explore how that needs to be done. Okay, sir?
Thank you, sir. Thank you so much.
Somebody, Jasmine KS, asking in the chat, can you tell difference between RCI and HCI based on features? Human RCI is, sorry, HCI is human computer interaction. RCI is what? Can you type or can tell somebody what is the long form of RCI? HCI, I know. What is RCI? That Jasmine KS. Can you tell what is RCI so that I can link HCI and ICI?
Robot computer interaction.
What is that?
Yes. Robot.
Oh, robot. See, what happens is in case of human computer interaction, um, it is say related to, say, human is there, computer is there, speech is coming into picture. And means when you speak to that, it will do something and it will get back to you. Now if you replace computer by human beings, then robo computer, so sorry, robo computer robo itself is a computer. Then robo computer interaction means, can you say two robots are competing communicating each other? See, human computer means human and computer is there. Computer can be even robo also, for example. And robo computer interaction. See, robotics, robo, what is computer? What you mean is, I think this is plain desktop, all those things. Not necessarily this robo itself is a computer, because in the brain of the robo we have all CPU, like memory, input output device. Robo to robot computer, robo to robo, sorry, robot to computer interaction is meaning that that becomes too much artificial intelligence, madam. That will be a tough task, I think. Yeah. Am I answered your question, madam? Yeah.
Jasmine, madam.
Sir, many research are going on in that direction.
Okay.
Okay, because see, that's why I told, no, after 140 years there won't be any human beings. They have to communicate each other. That is true. That is a new area, madam. People are exploring.
Yeah. Okay, sir.
Yes, yes.
Any other quick question may be asked now? From the audience.
Audience.
So, if there are no more questions, let me thank Professor Suryakant for his broad coverage of many techniques. For example, speech to speech, speech to text to speech, and also machine learning techniques. and so many areas are covered. So the talk is very inspiring to our audience. I hope that our audience will explore further in this field based on this presentation. Thank you,
Yeah.
sir.
Yeah, thank you, sir. Thank you for giving me an opportunity to share my research thoughts. Yeah, thank you, sir. We'll keep in touch. And any
Yes.
audience have anything to be asked that is any help regarding this, they can contact anytime to me. I'm happy
Yes.
to do that. Yes, sir.
Thank you. Thank you,
Yes,
sir.
sir. Yes, sir. Yes, sir. Yes, we'll keep in touch, sir. Vishwanath, sir. Yes, thank you, sir.
Oh, thank you. Now we will stop this session here. We will meet again at 11:30.